Good morning, guys. This is Dr. Turner for Integrated Math 2. Today we're going to be talking about rules of exponents. This is a review topic. It's covered pretty heavily in Math 8 and Integrated Math 1. If you've had me, you've seen this exact lesson before, but because it's going to come up at this semester, next semester, we're going to spend a little bit of time just reviewing the rules real quick. So be sure to take notes, pay attention if you don't have these already in your notebook. Let me get it set up here. Okay. So rules of exponents are basically just telling us what to do when we have exponential expressions, more specifically when we have exponents with the same base, okay? We have video links and things in the PowerPoints that are available to you on Schoology, but we want to focus here. Exponent, while we typically say exponent, we think of an exponential expression. The exponent is actually just the number up top. Anytime you have a text that is above your normal text line, we call that a superscript. So your exponent is any superscript. For us right now, those superscripts or exponents are always going to be numerical, meaning it's a number. It's not going to be a variable yet. And then the bottom, the one that's in the regular size font, is a base. The whole expression is what we refer to as a power. So the exponent is just the number up top. A power is the whole thing. Remember, when you're evaluating exponential expressions like this, it's not multiplication, right? This is not saying 5 times 3. When I have an exponent, when I have a superscript up top, that means that I am taking the base, in this case 5, and I'm multiplying it that many times. So 5 to the third power, or 5 cubed, is 5 times 5 times 5, which would be 125. Hopefully you're comfortable with your multiplication tables. If you're not, I recommend that you do so. It'll help this unit go a lot easier. And if you need to, you can always download a cheat sheet just to have it handy while you're practicing committing them to memorization. If it's a power that's higher than what you're expected to do, let's say it was 5 to the 7th power, that's the case where you'd want to get out a calculator or use a calculator like Desmos to evaluate it. In terms of exponents, there are 2 forms. There's the exponential form, which is like we just saw in any of these examples, like 4 to the 5th power, 3 to the 4th power, etc. And then there's expanded form in which we write it out. So for instance, if I wanted to write 4 to the 5th power in expanded form, I would write 4 times 4 times 4 times 4 times 4, right? So condensed, that's expanded form. And if I write it all out, that is expanded form. On a test like the CASP, you could be asked to go both ways. And so if we were doing this in person, I would ask you to kind of simplify these and either write it one way or the other. Again, we're going a little bit quickly because this should be a review. If you need a little more help, reach out to me, mturner@psasb.us, and we can spend a little more time on these. But I want to just kind of get you guys going on the Integrated Math 2 concepts. So your rules, there are a total of there's a total of 7 rules that I want you to be familiar with. So we'll kind of go through these again quickly. Your first is your negative exponents rule, which is defined as follows, and this should go in your notes. If the base is powered by the negative exponent, then the base becomes reciprocal with a positive exponent. What does that mean? It means that if I have a negative exponent, it is a shortcut or shorthand for having an exponent that's in the denominator. So whatever the negative power is, that is the same as 1 over x to that power. Okay? It literally represents exponential expressions that are in your denominator of a fraction. So what does that rule translate to in simple English? You flip it, you make it positive. So if you have a negative exponent, you want to flip it, meaning put it in the bottom, and make it positive. And if it was in the denominator, then you put it to the top and make it positive. When we are simplifying exponential expressions, we never want to leave a negative exponent. It's not considered simplified. So that's part of the process here once we put all of our rules together. So that is an important one to remember. So if I had 2 to the negative 4th power, for instance, again, you're going to flip it and make it positive. So that would be 1 over 2 to the 4th power. 3 to the negative 2nd power. Flip it and make it positive. That would be 1 over 3 to the 2nd power. 5 to the negative 3rd. Flip it, make it positive. 1 over 5 to the 3rd power, etc., etc., etc. we were doing this in person, again, we'd be going over all these examples, but because we're pressed for time, I'm just kind of trying to cycle you through. Okay. Your next rule that needs to go in your notes is your product rule. Product rule, when you are multiplying exponents that have the same base, the rule is you keep the base and add the exponents. So for instance, x to the 4th times x to the 3rd power, that would become x to the 7th power. We can also think of this in terms of expanded form. So if we were doing this in person, we'd spend a lot of time going over the rules, directly, indirectly, making sure that you understood how to write it in both forms. 3 squared times 3 to the 0. Again, you keep the base, you add the exponent. That would be 3 to the 0 power. Again, x to the 7 and 3 to the 2nd. The nice thing about the rules is that if you forget any of your exponent rules, you can still come to the same answer if you remember how to change between expanded form and exponent form. So for instance, here I got x to the 7. Well, let's say I forgot the product rule. I know that x to the 4th is x times x times x times x. And then x cubed is x times x times x. Well, how many x's? 1, 2, 3, 4, 5, 6, 7. That means x to the 7th power. Okay, that's another way to get to it if you forget your rules. And that same principle is going to be the same on all of these rules. Okay. Going along, your quotient rule, when you have powers with the same base, and remember, all of these rules are only applicable if the base or if the big number is the same. So here, if I am dividing by powers at the same base, I'm going to keep the base, subtract the exponents. So if I had 2 to the 6th divided by 2 to the 3rd, 6 minus 3, that's 2 to the 3rd power. If I had x to the 4th divided by x to the negative 3rd, keeping in mind my positive and negative numbers, and that's a whole other thing that should be reviewed, and you need to reach out to me if that's something you need help with still. You got to be able to add and subtract positive and negative numbers. So that would be x to the 7th, et cetera, et cetera, et cetera, et cetera. Again, all of these can be evaluated, if I forget the rule, by writing it out the long way. So for instance, that first example, if I have 2 to the 6th, that's 2 times 2 times 2 times 2 times 2 times 2. And 2 cubed, well, that's 2 times 2 times 2. So how many 2's cancel out? You have 3 pairs of 2's that cancel out. 3 2's, that's 2 cubed. Another common question that comes up when we do these sections is, okay, well, do I leave it as 2 cubed or I evaluate that as 8? For me, both. I want to see that you're able to evaluate the expression, meaning you know how to use the rules, which is what you're being tested on. And then if you want to write it out, you write the 8, that's fine. But if on your work you just tell me 8, that doesn't tell me you understand the rules. That tells me you just type something into the calculator, which is not acceptable. Okay, that is your quotient rule. Your zero law of exponents rule. Any base powered by 0 exponent equals 1. So anything to the 0 power is always going to be 1. Very common mistake, because at 0 we assume, oh, well, anything at 0 is 0. And that's true of other properties. That's true of multiplication and, etc. But it's not true of exponents. If it is something to the 0 power, it will always be 1. Now we can write that out and figure it out using our quotient rule, but because we're taking this at an accelerated rate, I'm not going to go through the process of how you get 1. You just need to know that it's 1. Okay? So again, it doesn't matter what the expression is. X to the 0 is 1. 10 to the 0 is 1. Negative 5 to the 0 is 1. 142 to the 0 is 1. Pi to the 0 is 1. Any expression to the 0 is 1. You then have your power of a power rule. So in this case, if you have a power and you're raising it to another power, your rule is to keep the base and multiply the exponents. Now, you've already experienced using Schoology and Google Classroom that when you are typing, sometimes you don't always have access to a math equation editor. So sometimes you're going to see the expression written like this, whereas if I had this in an equation editor, I might see this and then this, where the power has another power. It's higher. It's a superscript. It's above that m. Just keep that in mind, depending on your textbook, depending on what the assignment is. You can see them written different ways. They're all referencing the same thing. And again, power of power rule, keep the base, and you're going to multiply the exponents. So 2 cubed, it's 2 to the 9th power. 3 squared, cubed, 3 to the 6th power. -1 cubed to the 5th power is -1 to the 15th power, etc., etc., etc. If you forget your rules, right, you can always break it down. Like I know 2 cubed means this is 2 cubed 3 times. And each of these 2's cubed is 2 times 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 2. And how many 2's are there? There's a total of 9. So if you forget the rules, you can always write it out in expanded form and still get the correct answer. Your last 2 rules are a combination of both your product and power rules, or your quotient and power rules. Here, power of a product. The product of the bases is powered by the same exponent, and the result is a multiplication of individual factors of the product, each powered by the given exponent. What does that mean in English? If I have a product inside, basically what I can do is I can take that exponent and I can distribute it to each thing inside the parentheses. And that's not usually how distribution works, but that's essentially what this translates to. So what does that look like in terms of the PowerPoint? Well, okay, if I have 3 times 2 to the 4th power, now my order of operations says I need to multiply what's inside the parentheses first, right, PEMDAS. But if I distribute the exponent, I'm going to get the same thing because I don't have any addition or subtraction inside the parentheses. So what this rule is basically telling me is that instead of doing 3 times 2 and then raising that to the 4th power, I can distribute it. So this would become 3 to the 4th power times 2 to the 4th power. And depending on the assignment or teacher or text, you'll be told to either simplify it or leave it as an exponent. So pay attention to the rules in your assignment. Here, -3 times 2 squared, I can distribute the squared. So -3 squared times 2 squared. 0 times 4 to the 10. 0 to the 10 times 4 to the 10. There's always going to be different ways to approach these assignments, even like here, right? If I saw this and I was just asked to evaluate, I know 0 times anything is 0, right? So it doesn't really make sense to distribute the 10 and try to evaluate those expressions. But here we're trying to understand what the power of a product rule is, which is what we just did. And then last but not least, you have your power of a quotient rule, which is the same concept, but instead of multiplication inside the parentheses, we have division. We can distribute that exponent. So if I had an expression like x over y to the m, I could rewrite that as x to the m over y to the m. Again, basically distributing the exponent. So here, if I have 1/2 to the 4th power, and this is important, especially because when anyone has a, if I ask you 2 to the 4th power, you can do 2 times 2 times 2 times 2. If I ask you 3 cubed, 3 times 3 times 3. But the second fractions are involved, people kind of hesitate. This is a way to address that. So if I have 1/2 to the 4th power, it's 1 to the 4th power over 2 to the 4th power, which gives me 1 over 16, because 2 to the 4th power is 2 times 2 times 2 times 2. These rules are meant to be shortcuts, but remember, you can always get to the correct answer by writing it out in expanded form. So if I had 2/3 to the 5th power, I could do 2/3 5 times. And then remembering how to multiply fractions, as I know you all do, 2 times 2 times 2 times 2 times 2 would give me 32. And 3 times 3 times 3 times 3 times 3 would give me 243. Okay? So that's what this section is about. The rules are meant to be your friends. They're meant to be shortcuts. Once you master them all, it's fair for me to give you a question that involves one or more of the rules. I might ask you to simplify an expression involving one or more of the rules, and that's fair game, especially because it's review. But that's all for now for 1.2, guys. I hope the video helped, and have a good day.